All right, so this is what we did yesterday. It's a two-way frequency table. It's comparing two things. It's comparing their preferred drink of choice to their age. All right, so two categories here. How many total people took this survey? To get that number, you're going to find where the total of the first category meets the total of the second category. So you'll take this total and see where it meets this total. That bottom right-hand corner is your big total. So that would be the total number of people that took the survey. So in this case, that would be 100. All right? So probability of coffee. Before we get into that, yesterday we learned this thing called conditional probability, the given probability. And the given probability is going to happen for problems like 7 and 6, right? When you have that line, that's a given probability, okay? For those two problems, your denominator is going to be different. But if the problem doesn't have the line in the middle, then your initial denominator will always be 100. So my denominator for number 2 is going to be 100. My denominator for 4 is going to be 100. My denominator for 5 is going to be 100. My denominator for 8 is going to be 100. And my denominator for 9 is going to be 100, right? So if the problem is not a conditional probability, meaning there's not a given line, your denominator is going to be that total, which is 100. Now that might change after you simplify it, all right? So for this second one, it says probability of coffee. It doesn't give you an age preference, so I'm just looking for total coffee. What's that number, total coffee? 40. All right, so I'm going to coffee, and I'm going down to total. So this would be 40 out of 100. And then you should reduce that fraction if you can. So 40 divided by 100, math, enter. I think that's 2/5. Anybody have questions on that one? All right, so this next one says a 40-year-old who likes coffee. It doesn't say a 40-year-old or coffee, right? I just want like that specific category of people where the 40-year-old intersects with the coffee. So if I used a highlighter here, it would be like 40 to 49 meets coffee, right? They meet at the 11. So the numerator for this one would be the 11, right? There are 11 40 to 49-year-olds who chose coffee, and that fraction doesn't reduce. So I'll just leave that as is. All right, now this next one here says 20 to 29 or 50 to 59. So this or means that this is either going to be mutually exclusive or overlap. So I have to ask myself, is there a person who is 20 to 29 and 50 to 59 at the same time? You can't be two ages at the same time, right? So the answer is no. If I were to highlight the 20 to 29-year-olds and the 50 to 59-year-olds, there's no overlap, meaning they never intersect. They never meet, okay? So this is mutually exclusive. To calculate mutually exclusive probability, you take the probability of the first event and you add it to the probability of the second event. So I'm going to have 2 fractions out of 100 that I'm going to add together. 100 because it's not a conditional probability. So there are 33 20 to 29-year-olds, and there are 22 50 to 59-year-olds. So that's 55 out of 100. And I can reduce that by dividing by 5 to get 11 out of 20. You can just type that in your calculator too. You don't have to do it by hand. Questions on that one? All right, now the next one is conditional probability. I found that a lot of you struggled with this one on the ticket out. It was the last two. A lot of you were struggling with what the denominator should be, all right? The denominator should be the category that's second, okay? My denominator is going to be the total water, all right? That's what this is saying. It's saying, well, what are the chances someone's 50 to 59? But the condition is they got to be in the water category. So I only want to focus in on the people in the water category, so I'm going to use the water total, all right? So I'm going to use only the water numbers, which means my total is going to be 28. So of those 28 people, how many are 50 to 59? 6. So it's the 50 to 59-year-olds who like water, that's 6, over the total water. The second category is the denominator, right? And then that reduces to 3 out of 14. These are the only types of problems where the denominator's not 100. The next one, the condition, is the 30 to 39-year-olds, right? The second category is the one that you want to focus in on. So here are my 30 to 39-year-olds, and my total in that category is 26. So my denominator for this one should be 26. So of those 26 people, how many picked soda? 5. And that fraction doesn't reduce. All right, so just pay attention to the second category for your denominator. It's the second one. The numerator is where the two categories meet up. The denominator is the second category. That's the condition. Not 20 to 29. Well, this is called a complement probability. This was that one day, remember where the Canvas assignment didn't work out? It wasn't here. All right, so to find a not probability, you're going to take the total, which is 100, and you're going to subtract the 20 to 29-year-olds. So there are 33 of them. All right? And so if I do that subtraction, I get all of the other people, right? So one way to do it is to subtract them. The other way to do it is you could just add the 30 to 39 total, the 40 to 49 total, and the 50 to 59 total, right? All of the ones that aren't 20 to 29. I like to do the total minus the actual category, and that will give me the rest of them. And that fraction doesn't reduce. Same thing here, not t. So I'm going to take the total, which is 100, and I'm going to subtract the t, which is 17. All right, so that will give me my numerator number, and that fraction doesn't reduce either. All right, so these are my final answers here. I'm going to circle them so they stand out a little bit. Conditional probabilities are the ones where the denominators changed. Now, we added in this 30 to 39 or t. The fact that there's the word or there means it's going to be mutually exclusive or overlap. So you have to ask yourself, are there 30 to 39-year-olds who picked t? Yeah, right? That category exists. If I were to take a highlighter and highlight the 30 to 39-year-olds and another color, so I'm picking a second color here, and I'm going to do the T. They physically overlap, right? They intersect at 5. So there is an overlap here. So to calculate this probability, I'm going to take the 30 to 39-year-olds. That'll be my first number. So the total 30 to 39-year-olds is 26. And then I'm going to add, because or means add. So I'm gonna do 26 for the 30 to 39-year-olds, plus the total people who like tea, so the whole category of 17. And I'm going to subtract the place where they meet. This is the overlap. So I'm gonna subtract 5. All right, this is not a conditional probability. There's no given line. So my denominator of all of these fractions is going to be 100. And you can just type that into your calculator. So it's 26 out of 100 plus 17 out of 100 minus the overlap. Math, enter, enter. 19 out of 50. So my original goal for today was I had a whole math Excel assignment created that was going to lock at the end of class, and I was going to give you class time to just practice. After seeing that ticket in, I don't think you're ready to be doing an assignment on your own. So I kind of want to make today more interactive than I had planned, to just really make sure you're okay with this. A lot of you struggled on that ticket out yesterday. This part and the top. So I created an assignment for today where we can do some more interaction and make sure you're okay. So it's going to be a check-in. We've done these before. The front is going to be all of the beginning of the unit. So like finding a single probability, finding mutually exclusive, overlap. The back is the two-way tables, which is the stuff we did yesterday, all right? I'm going to have you do this a page at a time. So you're going to complete column A of the front on your own, and then you're going to come see me. I'm either going to send you to column B, and I will explain to you why, or I'll send you to the back. Once I send you to the back, you'll do the same thing. You'll do column A, and then you'll come see me. I'll either send you to column B or the anchor. I have the anchor to be the test review guide. I don't need you to do that today. It's just there if you need something to do. If you want to work on something for another class, that's fine too. In a moment, after I pass this out, I'm going to let you grab your phones, but the phones are for music, not for anything else, right? We're not playing games. Like I'm going to keep track of who I see. I want to see you today for the front and the back. At minimum, you're doing 15 problems for me today. And at maximum, you'd be doing 45 if you got everything wrong 3 times. I really hope that that's not the case, but we're looking minimum 15, maximum 45. Questions before we get started? All right, for the front page, it is a problem about jerseys, and a lot of you struggled with that one yesterday on the ticket out. So I wanted to create an image so you can physically see what you're working with. This is what you're working with. Everybody's working with the same amount of jerseys that are the same color. All right, you can grab your phones. I'm going to get these passed out to you.